That's just a little wedge imaging that I picked up recently for parts, and these industrial control boxes are quite useful sources for all manner of different parts. In this case, it's a corrosion oil pump set, model F0TP4. It's also hideously expensive, but it's a good source for all kinds of parts, as I just said. Little indicator light things, although they take these somewhat unusual, although they are standard and somewhat common, just not in any kind of physical store usually. PSB, or no wait, 120 PSB telephone slide base lamps. Basically the reason they take these, at least as far as I can determine, is because these are typically 120 volts. Although you can also get 55 volt ones which are intended for telephone use. This is why these are called a telephone slide base, because they were originally commonly used for indicators and telephone switching stations. Whereas the miniature bayonet base lamps are more typically available in much lower potentials, although you can get 120 volt and 130 volt lamps. They're not screamingly common, whereas these things rated for anywhere from about 6 volts to 28 volts are really common. You can even get them as low as 2 volts in the case of the Type 49. But basically it's so that whoever is relamping the panel doesn't inadvertently stick a much lower potential lamp in there, and then as soon as it makes electrical contact and the lamp turns on, it explodes, which if the contacts in the lamp holder are alive when the guy puts the lamp in, lamp explodes, and of course you got broken glass embedded in the guy's fingers, and you have the remains of the lead-in wire assembly, which have good 120 odd volts on them. Also got this little Heat Timer Corporation Digispan. It's basically a transducer operated relay. It runs on 24 volts AC. That's why there's so the purple wires are for it, of course. So that wouldn't be an electrocution hazard under most things, but then again, in an industrial type application, you're not going to be randomly sticking your fingers on terminals, at least not if you want to live long. And of course, the thin wires are just for the transducer that this reads. There's the switches, quick default. And inside, you got the back side of the switches and all the idiot lights, just wires, blah blah. Fairly standard wiring loom. 2 purple wires being the 24 volts, most likely a different color just because they're a different operating potential. There's the 24 volt transformer for running the relay, as well as a 500 volt ampere control transformer for running everything else. Of course, the difference between a control transformer and a conventional power transformer is that a control transformer is intended for dealing with loads where you have a really high inrush, predominantly contactors, because mechanically inside the contactor, the assembly that the coil pulls in, before it actually pulls in and completes the magnetic circuit, the inductance of the coil is much lower, and thus the operating current is much higher, because the relations for inductance are much like the relations for resistance. Basically, it's an inverse proportionality as far as the inductance versus the current and power, blah blah, just basic AC circuit schmoo. So yeah, that's why it's got the control transformer in here, because it's got a number of relays and contactors. The reason, the difference between a contactor and a relay, of course, being that a contactor is a relay that's intended for really high operating currents. For example, these are fairly small, only a few hundred volts, most likely in the 10 to 20 ampere range, whereas you can get much bigger contactors like this guy. This one's good for 60 amperes per contact set, but these also have integrated, integrated ones might be different things, but these are adjustable overload trips. Something you need when you're controlling motors a lot of times is basically a way to shut the motor off if it gets overloaded. So the way these work is you just have a little dial that you set to the current, in this case 3 amperes, but it's settable anywhere from 2 amperes to 7 amperes, and when it exceeds 3 amperes for an extended period of time, it trips, which you can manually do by just pushing down and turning the little blue thing on the right, and just to reset it, there's a little yellow flag window just to say that the thing has tripped. And of course it's mechanically indicated because there's nothing to burn out like an incandescent lamp or an LED, which can fail, especially in industrial control stuff where you got all kinds of transients and nasty schmoo on the lines. Also, it's almost like an electrically actuated trip thing. just for testing the functionality of the electronics inside it, whereas more conventional motor starters have replaceable heaters. Like for example this one, it's 8.73 amperes. It's very common for them to be oddball current ratings because those current ratings correspond to the typical overloads of a given size motor at a given potential. Or this one where the heater, this Siemens one, where the heater just screws onto those two things. Or they can take the screw, move it over, or just replace these with a wire link or a fuse or something, and turn it into a DC rated wall switch, which is the entire reason why I had this guy. That was also General Electric. That's the difference, because it's very common for these things to have their own obscure things, like the motor starter heaters, partly to ensure compatibility, partly because industrial control schmo, getting more money. Also, delay relay, these are quite useful. This isn't one of the really fancy ones, this one. While it's adjustable for a whole range of different settings, you have to tell the relay what the legend is set to. The little thumb wheel, in this case it's set to number 3, and there's a little legend on the side of it. The really fancy ones have little dials that poke through the, or that are accessible behind the attached front cover. This one actually peels off so you can get to the thumb wheel and adjust the legend. And you can set it from the front, and when setting it, it moves the legend, and it also adjusts the internal settings in the delay relay electronics. So those are much more convenient if you're doing, either if you're using the relay in a number of different experiments, you need to change its values all the time, or if you need to, or if you have one thing but you're always needing to, or you need to adjust the delay quite frequently. And then of course there's a pair of regular, conventional 4-pole, double throw, 120 volt relays. That one's also 120 volts, but it's octal based. And it's also got a little terminal strip, which are quite useful. And fuse blocks. So these are fairly standard midget fuses, and whoever put these in was intelligent. And also, you wouldn't ordinarily be doing this because it'd be 208 volts between all these terminals. This is a 208 volt single phase controller, by the way. And this is a very good practice to do, is with these cartridge fuses, put them in so that you can actually read what the what legend printed on the fuse is, because oftentimes you'll see something like these, which are some battery protection fuses I got for the solar farm, but these fuses came with these fuse blocks came with the fuses. Whoever put the fuses in didn't put them in so that you can read the legend. So I think these are 200 amperes, but I'm probably going to be getting 250 ampere fuses if they're available, or 300 ampere fuses just because these are for critical, basically main battery connection fuses for protecting the line running to the DC breaker box, which is that thing. This is actually why I got this. I'm just going to use this as a, put a dump load controller in here, as well as just use it as a breakout box for us being able to stick more charge controllers on this, because I'd only be able to fit maybe 1 or 2 Midnight Classics on top of this guy, and I'd probably have to punch new holes in it. But yeah, that's just a schmoo for the solar farm.